In this video, we will explain the resistor connections. There are two types of electrical circuits: series circuits and parallel circuits. Series circuits, in these properties, the components are connected end to end, one after the other. They make a simple loop for the current to flow around. If one bulb blows, it breaks the whole circuit and all the bulbs go out. In parallel circuits, the components are connected side by side. The current has a choice of routes or paths. If one bulb blows, there would still be a complete circuit to the other bulb, so it stays lit. In series circuit, electrons only have one path to flow through, but in parallel circuit, there are multiple paths for the current to flow through. In series circuit, the resistor resists the flow of electrical current. Increased resistance will reduce the rate at which charge flow. Total resistance goes up with each resistor since the current must go through each resistor. Total resistance will equal sum of all resistors in the series, like R total will equal R1 plus R2 plus R3 plus R4 if it exists. In parallel circuit, resistor in parallel circuit added side by side. The more paths, the less total resistance. 1 over total resistance will equal 1 over resistance 1 plus 1 over resistor 2 plus 1 over resistor 3. Exercise: two resistors in parallel with, like this is 4 and this is 4. So 1 over R total will 1 over 4 plus 1 over 4 will equal 2 over 4 will equal half. So the R total will equal 2. Since the circuit offers two equal pathways, if the charge only have the charge, we'll choose path through a given branch. Series circuit in current will equal amount of charge flow of. What is a current? Current is amount of charge flow of electrons, like the flow of water. A current can just disappear. Since only one path, if some electrons flow through R1, then they have to contain flowing through R2 and R3. So, to calculate the current, I total will equal I1 will equal I2 will equal I3. In parallel circuit current, all paths are used, but the charge divide up into all branches. One branch can have more current than another branches. It depends on the resistance and branch. This may be 2 or this may be 4, 3. Total current will equal the sum of current in each path. Like if we have this is I, and this is I1, and this is I2, and this is I3. So I1, so this is I2 plus I3. This is I2, so this is I3. This is I3. If we return it to back, this is I3, I2 plus I3, I1 plus I2 plus I3, the total I. Series circuit in voltage. Voltage is the electric equivalent of water pressure. The higher the voltage, the faster the electron. If the voltage be higher, the electron will be faster flow through the conductor. Each component has resistance that causes a drop in voltage. Total voltage in series circuit equals the sum of voltage across each series resistor, like V total equal V1 plus V2 plus V3. In parallel circuit, voltage in parallel circuit charge only pass through a single resistor. Voltage drop across the resistor that it chooses to pass through must equal the voltage of the battery. Total voltage will equal the voltage across each individual resistor, like V2 equal V1 equal V total equal V1 equal V2 equal V3. This is summary of comparison. Voltage in series, V total equal V1 plus V2 plus V3. The current I total will equal I1 equal I2 equal I3. Resistance R total R equal R total will equal R1 plus R2 plus R3. In parallel, the voltage total volt will equal total voltage will equal voltage 1 plus voltage 3. In current, I total will equal I1 plus I2 plus I3. And the resistance 1 over total R equal 1 over R1 plus 1 over R2 plus 1 over R3 plus 1 over R4. And this so in this question you will try to measure the current and voltage and try it by yourself.